students, I welcome you once again to today's concept. We are still on the polynomial functions. As I said previously, that in our next video we are going to look at remainder theorem and factor theorem. That's what we are going to deal with today's lesson. My name is Evans Okan. I'm your mathematics facilitator. This is Mazways TV. Kindly subscribe, like, and share the videos. So today we are going to look at this beautiful concept before us, and that is remainder theorem. We've done most of the basic ones. If you recall, we did multiplication, addition, subtraction. We also use the long division approach and the synthetic approach to divide polynomial functions. Yes. So all that we studied, we are going to need them here. Okay. Yes. So let's move on to the concept remainder theorem. Great. So as I said previously in one of our previous lesson when we started with the division of polynomial functions, I said that every polynomial function can be written in the form dividend is equal to quotient times what divisor plus remainder, or we can also say it is what improper fraction, which is given as quotient plus remainder all divided by divisor. So every polynomial functions that you get, you can write them in this form. Okay. Yeah. So if we are saying that you have a polynomial function, let's say p of x. If you have a polynomial function given as what p of x, and that p of x is divided by x minus k, then we can write the polynomial function as what? P of x is equal to q of x times x minus k plus r. So the q of x represent what? The quotient. My capital R also what? Represent the remainder. And the p of x is the polynomial function given. Yes. So every polynomial function, as long as it is divided by x minus k, can be written in this form. All right, good. So if let's say this is what you have now. So for this concept, let's find the zero of x minus k. We've done this previously, so I know you can remember all that we said when we had what? X minus k. So if you had to find the zeros, then it means it's going to be x minus what? K, which is equal to 0. So to find x, you can just transpose -6 to the right side, and that will give you what? X is equal to k. Once you have x to be k, then what do? You have to substitute it back into the polynomial function. So if you should substitute the value of x, which is k, then what are you going to get? That means you are going to get p of k, which is equal to what? The quotient times 0, because when you substitute x for k, or if you substitute k for x, at the end of the day, you are going to subtract k from k, and that makes what? The work, that area go what? 0. So if you multiply the quotient by 0, it means that automatically that portion will go, and that leaves what? P of k to be what? R. And what did I say? The R is the remainder. So when we talk of remainder theorem, that is when we can divide any polynomial function. If you do it this way, definitely you are going to be left with a given number, and that suggests what? The remainder theorem. Have you got it? So this one is the fastest way we can use to find the remainder. You see, we used the long division approach and the synthetic approach to find the remainder and the quotient, but this is the fastest way. All right. So for the remainder theorem, that is what we are talking about. Okay. So if you are given a polynomial function to divide it by another polynomial function, or let's say you are given what a linear function as x minus k, what do? All that you do is you just find the zero of that linear function, then you just substitute what the value of the x. Okay, you substitute the value, you work out whatever is left is the remainder. That's what we are talking about. Okay, so that is the principle of what remainder theory. All right, that's good. Now let's try and take an example and see how we can find the remainder. So for instance, if you have this, um, so let's take this as our first example. We are to find what the remainder when f of x is equal to 3x cubed plus 4x squared minus 5x minus 2 when it is divided by x minus 1. So this one, you see, when we're doing the long division, or when we use the synthetic approach, you can use this once you realize that the divisor, so the divisor in this question, as it is given as what x minus 1, because it is a linear form, you can use the synthetic approach to find the remainder. You can also use what the long division to find the remainder. But in this case, for the principle of what remainder theorem, what it is saying is that we can use the remainder theorem to find the remainder. Okay, you follow that principle. What do? You just find the value of x given in the linear from the divisor. Okay, so once you have the divisor, you can solve for that and substitute the values you get into what the function given, or the polynomial function given. Then whatever you get becomes your remainder. That is what we are saying. So let's go through our solution and see how we can find the remainder of this question. Okay, so this is a remainder. As I said, we find the zero of what the linear function given. So if we are to find the zero, then that means we are solving for what x, and whatever we get, we are going to substitute the value. So if we are to find the value of x, then we can get x to be what 1. We can get x to be 1. Once we've gotten x as 1, what do? You only have to substitute the 1 for x in the function f of x, and then you work out and get your answer. So when we substitute 1, this is what we are going to get. We are going to get f at 1 is equal to 3 multiplying what 1 cube plus 4 multiplying 1 squared minus 5 multiplying what 1 minus 2, and that is 3 plus 4 minus 5 minus 2, and that gives what 0. That gives 0. So we've gotten what 0. Once we've gotten 0, then we can conclude that the remainder is what 0, because that is what is left when you substitute the value of x, which is 1. When you substitute the value, you are going to get 0. Okay, so that 0 you have gotten, that becomes what your remainder. Okay, yes. So if you can also use the long division or the synthetic approach to work out this, you realize that you get the same. That is great. If that's the case, then let's try and solve another example and see how things will go. All right, great. Okay, so let's see if we can take another example and see how we can do that. So for the Second example, it says what, determine the value of n if p of x is given as 18x cubed plus nx squared minus 8x plus 9, which is divided by 2x minus 1, and the remainder is what, 2. So looking at this question, you could see that the remainder is already given. The previous one, we were asked to find the remainder. That's what we did in the previous or in the example 1. But for example 2, we had to find the value of what, n. We don't know what n is, and the remainder is also given. So let's see how we can solve this example. Okay, so for our solution, as I said, once you are given the polynomial function and the remainder, always, first of all, you need to find your the divisor. You need to find the zeros. Okay, you need to find the zeros of the divisor, and whatever value you get, you substitute into what, the polynomial function given. Now we have it as this. So you have 2x minus 1, which is equal to 0. So to find the zeros, then we are going to get 2x is equal to 1. We divide both sides by 2. All right, good. So if we divide both sides by 2, then we are going to get x to be what, and 1 on 2. That is what we get. Okay, so once we are able to get the value of x, then what do? We just substitute, that's what, half. We substitute the half for x in the polynomial function given above. Okay, great. So let's quickly do that and see how we can and you also know that we have been given the remainder. Now, one thing you should understand is that um, whenever you find the zeros of the divisor, okay, whatever value you get, when you substitute into the function, it gives you what, the remainder. Yes, that is what it is saying. That means the x is equal to half is our what, divisor. Yes, it is our divisor. So it means when you divide that polynomial function by the divisor, you are going to get a remainder of 6. That is what this question is saying. Okay, so if that's the case, then which value of n, are we going to get if we divide the polynomial given by the divisor? Okay, that is what we are going to look at. Okay, great. So let's see how it is. So you only have to substitute the value of what, x, which is half, into the function, and once you do that, you are good to go. So because we have x cubed, then we can get what, 18 multiplying half cubed plus n multiplying half squared minus 8 multiplying half plus 9, which is equal to the remainder given in the question. Because why are we equating to 6? We are equating to say 6 because we are saying that when you divide that polynomial by the 2x minus 1, the remainder is 6. It means when we substitute the x value for, which is half, when we substitute into the polynomial function, our remainder should be what, 6. That is why we have equated to 6. Then once you do that, what do? You only what, have to find the solution. Okay, yes, so that is great. Okay, now let's see, let's make some corrections here. I think in the question we were given n, so instead we've rather written what, m. So let's try and make the correction here. Okay, instead of m, so we are going to make the correction. Okay, all right, so great. Okay, okay, so we've made the correction, so it's supposed to be n, not m. Yeah, so you substitute your value, and this is what you are going to get. Okay, good. So let's do the simplification. Okay, now you are taking what? Cube of half. So when you see anything like this, okay, fraction, when you are taking exponent of fraction, how do you do it? Know that the exponent, which is 3, affects each of the numerator and the denominator. Have you gotten that? Yes. So you could see that 1 cube divided by 2 cube. Yes, that is how it is done. Then if you go to the n, multiplying half, that one, the same applies there. 1 squared, 2 squared minus. Yes, so take note of this. Whenever you are dealing with such, you should know how to go about it. Know that this is how you are going to do it. Okay, so if that's the case, then what is my 1 cube? 1 cube is still 1. What is 2 cube is 8. And then 1 squared is 1. 2 squared is 4. Okay, so once you are done, then you further what? Simplify, and you are going to get what? So 18 multiplying 1/8 gives you what? 9 on 4. And then n multiplying 1 on 4 also gives what? N on 4, because n is multiplying that fraction, so it's going to give you n on what? 4. And then 8 multiplying what? Half, so it means that half of 8 gives us what? 4. You know that. And then we have our 9, which is equal to 6. So once you have this, what do you do? So you have fractions of linear equation. We've done this in core mathematics or mathematics. Yes, this is what? Fractions involving, or linear equations involving what? Fraction. We've done that. So what do you do when you see it like this? All that you do is what? You find the LCM. Okay, you find the LCM, and in this case our LCM is what? 4. So once you are done looking for the LCM, what do you do? All that you do is what? You just have to multiply through by the LCM you have gotten, which is 4. Okay, so we are going to multiply through by 4. If that's the case, then we are going to have this. So 4 multiplying 9 on 4 plus 4 multiplying n on 4 minus 4 multiplying what? 4 plus 4 multiplying 9, which is equal to 4 multiplying 6. And in that case, we are going to have 9. When you multiply that, the 4 will cancel the 4 out, or it will cross the 4 out, leaving 9 behind. The 4 also multiplying n on 4, the 4 will also cross the 4 out, leaving n behind. Then we have negative 4 multiplying 4, which gives negative 16. We also have 4 multiplying 9, and that is also 36, while 4 multiplying 6 gives us what? 24. So once you have this, how do we find n? It's just by grouping like that. So we can decide to maintain n at the left side and transpose the rest of the values to the right side. Okay, and that is what is done here. So n is equal to 24 plus 16 minus 9 minus 36. Okay, in all, our n becomes what? Negative 5. So you see, this is very beautiful. When you have questions like this, that is how you go about it. You don't have to waste much time on this. Okay, yes, that is how it is. So that is the remainder theory. We have more questions that we can solve. All right, so we shall be looking at more questions on this. But for today, let's end here and continue next time. Okay, so in our next lesson, we are going to solve different kinds of examples. We are going to solve different questions on the same remainder theory. All right, okay. I'm Sir Evans. I'm your mathematics facilitator. The name of this channel is Maths with TV. Don't forget to subscribe, like, and share. Bye bye.